Welcome back. Today we're going to look at some more variation questions. Still working on that learning target to recognize and use inverse variation, but we're also going to talk about a couple other different types of variation. So quick review, when constructing variation formulas, remember our two basic formulas. If it says varies directly, we need to use y equals k times x. If it says varies inversely, we need to use y equals k divided by x. So our process is we set up the structure of our variation equation based on if it's direct or inverse. We plug in our values that they give us for our variables and use those to find k. And then once we know k, we can plug it back into our actual equation. All right, so our first one, it says, write a function that models the variation. Z varies directly with x and inversely with y. Now notice on this one we have two separate pieces. It varies directly with x. Sorry, we'll do that one. Try to keep them color-coded here. Directly with x and inversely with y. So what that tells me is when I go to set up my basic equation, z varies. So z equals a constant of variation, and then directly with x means we're multiplying it by x, and inversely means we're dividing. Now notice here that we have three variables, x, y, and z. So it's similar to the ones I highlighted up here. All right, but we have to watch the variables they're giving us. So z varies means z equals. Directly means the x is getting multiplied to k. Inversely means our variable is getting divided. So we're dividing out a y. Then they give us an x, y, and z that works in this variation formula. So they tell us that z is 2 when x is 4 and y is 6. So I just replaced my variables with those. We said z was 2, x is 4, and y is 6. Simplifying this, or solving for k, we multiply our 6 up, so 12 equals 4k, and then divide out our 4, so k would be 3. Once we know that, we do our third step. We actually write the equation, and that uses our k value. So our final answer would be z equals 3x divided by y. So once we know k, we can put that back in and get our specific equation. All right, next one, it says z varies. So again, z equals. Now jointly means a direct variation but with multiple variables. So if it says varies jointly with x and y, it means direct with x and direct with y. Okay? So z equals kxy. We are told that x is 3, y is 5 when z is 60. So I'm going to put a 60 in for z. I'm trying to find k. We know x is 3 and y is 5. So 60 equals 15k. We're going to divide by 15 and we end up with k equaling a 4. So then I go and write my actual equation. Z equals, my k value is 4 times x times y. All right. Go ahead and pause the video and you guys try this one. Okay, let's check what you did. Z varies, so z equals jointly, and remember there's always that constant of variation in there, jointly with x and y. So x and y are getting multiplied to that k, and inversely with w. Any kind of inverse means it's on the bottom. We're dividing it out. So there's my format. Now I'm going to plug in my values. We are told that z is 16. Our x value is 4, our y value is 2, and w is 5. Okay, simplifying this, 5 times 16 would give us 80, and 4 times 2 is 8, so 80 equals 8k. Dividing, we know that k then has to be 10. So, final answer, we're going to plug that 10 back in, and we say z equals 10xy divided by w. All right, next one. Z varies directly with x. So z equals directly with x, so k times x, and inversely with the product y times w. Product just means you're multiplying. So y and w are multiplied together, but it's in the denominator because it's an inverse variation. Now we plug in our values. We are told that x is 3, y is 4, and w is 1 when when z is 6. So we have 6 equals k times our x is 3, our y is 4, and w is 1. All right, so we have 6 equals 3k divided by 4. We're going to multiply 4 over to the 6. We've got 24 equals 3k, which means k has to be 8. Now we can plug that 8 in. So z equals 8 times x divided by y times w. All right, let's try a couple word problems. Same idea, we just are hiding the information a little bit in a word problem. It says the number of bags of grass seed N needed to reseed a yard varies directly with the area A to be seeded and inversely with the weight W of the bag of seed. Find an equation that relates the variables if it takes 2 3-pound bags to seed an area of 3,600 square feet, and then use it to determine how many bags would be needed to seed 9,000 square feet. All right, so let's go through and break it down here. The number of bags of grass seed N needed to reseed a yard varies. So we have N equals, okay, it varies, so we have that constant of variation, directly with the area A, so directly with A, and inversely with W. Okay, so we've got our format. Then it says, find an equation that relates the variables if it takes 2 bags that are 3 pounds each. So the weight is 3 pounds. The number of bags, what did I use, green? Number of bags is 2, and the area is 3,600. Okay, so we have N equals 2, W equals 3, and A equals 3,600. That's what they've given me in the word problem. So we're going to plug those in. We have 2 equals our constant of variation times our area divided by our weight. They were 3-pound bags, so W is 3. Now to solve this, we're going to multiply the 3 over to the left side. So 6 equals 3,600 times K. When we divide that out, we end up with K being 1 divided by 600. That's what it would reduce to. 6 divided by 36 would be 1/6. So 6 divided by 3,600 would be 1 over 600. So to write our equation now, we're going to plug this back in for K. So N equals our K value, 1 over 600, times our area. So we're timesing by A. And we're dividing by W, so the W is going to go in that denominator for division. So we really have N equals A divided by 600W. Okay? Then it says, use that to determine how many bags of seed are needed to seed 9,000 square feet. So our weight, again, is still 3. We haven't changed that. We can substitute a 3 in here. And our area is now 9,000. So N equals 9,000 divided by 600 times 3, or 1,800. We end up needing 5 bags. Okay, let's look at another one. Gravitational potential energy, which we're going to use PE for that abbreviation, is a measure of energy. Potential energy varies directly. So PE varies directly with an object's mass and its height. Now remember, directly with 2 variables, 2 or more variables, could also be written as jointly. Okay, so PE varies, we have our constant of variation, directly with the mass and the height. Okay, it says physicists use G to represent our constant of variation. So we're going to replace K with g because it stands for gravity. Right? It's considered our gravitational constant. It says the skateboarder in the photo has a mass of 58 kilograms. So that's our mass. We're going to put that in for m. There's a potential energy of 2,273.6 joules. That's going to go in for PE, potential energy. And it says use this to find an equation that relates the variables. In other words, figure out what that gravitational constant is. Notice over here, it's kind of blurry here, but the height of the skateboarder is 4 meters, so that's going to be our h value. So our potential energy was 2,273.6. We don't know our gravitational constant. We know our mass is 58 kilograms and our height is 4 meters. So we are going to multiply 58 and 4 and then divide it to the other side. So take your calculators, 2,273.6, and we're dividing by the quantity 58 times 4. Okay? When you do that, you should get a constant for gravity of 9.8. So our formula that fits all of this information, potential energy equals g times m times h, but now we know g is 9.8. So 9.8 times m times h, mass and height. Then it says, what is the gravitational potential energy of a 65 kilogram skateboarder on the same half pipe shown? So we're still going to keep our height at 4, but this time we are going to plug in a 65 for our mass. So the potential energy is 9.8 times 65 times 4. Grab your calculators. We end up with a potential energy of 2,548 joules. All right, the last little piece we're going to look at. Sometimes you are given the equation and you're asked to describe the variation. So the formula is already written, they're just asking you to convert it back into words. For each of the following, we're going to use variation to describe how the variables are related. The hint, never describe k. K is that constant of variation. It's in every variation kind of equation. So we never talk about k. It's implied when we say the word varies. So we would write z varies, since it's z equals. So z varies, and since we have an x and a y, both being multiplied to our k value, we can either say jointly with x and y, or we could write this as z varies directly with both x and y. Or we could say z varies directly with the product of x and y, because product means that x and y are getting multiplied together. All right, for our last one here, notice that we're starting with a y, so we're going to say y varies. Okay, you're going to replace your equal sign with the word varies, and that takes care of your k value. So y varies, x is on top, so we say directly with x, and because the z is on the bottom, we're dividing it out, so that's an inverse variation. So y varies directly with x and inversely with z. Okay? All right, go ahead and try some of these in your homework and let me know if you have any questions.